Solar panel types. In the last video, we explained about what are solar panels and what are the uses of solar panels, what are the advantages. In this video, we will explain about the solar panel types, which you can see. So, I will share my screen with the solar panel types. There are three main types of solar panels, that is monocrystalline, polycrystalline, and thin film solar panels. So as you can see, monocrystalline solar panels are made of pure silicon. Polycrystalline solar panels are made of silicon crystals melted together. Thin film solar panels are made of a variety of materials. In terms of efficiency, monocrystalline solar panels have the highest efficiency among the three of around 21 to 24%. Polycrystalline a little less, about 18 to 20%, and a thin film about 17 to 19%. In terms of cost, thin film solar panels are most expensive. Polycrystalline are least expensive. Monocrystalline comes somewhere between the two. So the next type of thing is, what is the lifespan? Monocrystalline life solar panels last a long time. That's why they are preferred for most use cases in residential. Now, what is the carbon footprint while manufacturing these solar panels? Thin film solar panels are most environmentally friendly as they have the least CO2 per equivalent per kilowatt hour. So, what is the manufacturing method? Monocrystalline solar panels are used since about 1950s, and approximately 95% of the solar panels used today use monocrystalline. They are manufactured using the Kowalski method. A single silicon crystal is sliced from the ingot, resulting in a silicon wafer that is approximately zero point 0.3 millimeters in thickness. This is the diagram of a monocrystalline solar panel. So they are slower, more expensive to produce than any type of solar cells due to the precise way the silicon ingots must be made. In order to grow a uniform crystal, the temperature of the materials must be kept very high. As a, as a result of this, large amount of energy is emitted, and you can see why the COD equivalent per kilowatt hour is max in this type of panels. So up to 50% of the material can be wasted during cutting process, resulting in higher production costs for the manufacturers. But these type of solar cells maintain popularity for a number of reasons. They have higher efficiency, they are more produce the same type of or amount of electricity as others, and they have the longest lifespan. Biggest drawback is the cost. That is due to the cost of the production process. When light does not hit them directly, they are not as efficient as the other panels. That's the disadvantage. While monocrystalline solar panels remain popular, the low cost and rising efficiency of other solar panels are becoming increasingly appealing to consumers. Polycrystalline. Compared to the monocrystalline, polycrystalline are made of cells formed from a multiple or non-aligned silicon crystals. These first generation solar cells are produced by melting solar grade silicon and casting it into mold and allowing it to solidify. The molded silicon is then sliced into wafers to be used in a solar panel. Now, these are less expensive than the monocrystalline cells because they do not require the time and energy needed to create and cut into a single crystal. The boundaries created by the grains of the silicon crystals result in barriers for efficient electron flow. and they are more efficient in low light conditions than monocrystalline silicon cells. So, the polycrystalline solar panels are larger than monocrystalline counterparts, but due to the low capacity, they may require more number of panels to produce the same amount of electricity, and they are not as long lasting as their monocrystalline counterparts. Now, what is thin film solar cells? The high cost of producing solar grade silicon led to the creation of several types of second and third generation solar cells known as thin film semiconductors. They need a lower volume of materials, often using a layer of silicon as little as 1 micron thick, which is about 1 by 300th of the width of the mono and polycrystalline solar cells. Silicon is also lower quality than the kind used in monocrystalline vapors. This is the thin film solar cells. Many solar cells are made of non-crystalline amorphous silicon. Amorphous silicon does not have any semiconductor properties of crystalline silicon. It must be combined with hydrogen in order to conduct electricity. Amorphous silicon solar cells are the most common type of thin film cells and are often found in electronics like calculators or watches. Some of the materials or semiconductor materials, viable thin film semiconductor materials include cadmium telluride, copper, indium, gallium diselenide, and gallium arsenide. A layer of semiconductor material is deposited in an inexpensive substrate like glass or metal or plastic, making it cheaper and more adaptable than other solar cells. Now, production of thin film cells is much simpler and faster than the first generation solar cells. Thin film solar cells like CIGS can be deposited on plastic, significantly reduces its weight and increases the flexibility, thereby increasing the payback time. What are the disadvantages? The cadmium in CDT cells is highly toxic and, if inhaled or ingested, can leach into the ground or water supplied if not properly handled during disposal. This could be avoided if the panels are recycled, but the technology is currently not as widely available as it needs to be. The use of rare metals like CIGS, CDTE, and GAS can be an expensive and potentially limiting factors in producing large amounts of solar cells. Another type we will discuss in another video. So there are other types of emerging solar cells also manufactured, but that will be a topic for next time. Thank you very much.